Welcome to the MAN BMW Camshaft S engines, MEC engine, electronically controlled engine. So, first module we had discussed the basic concepts of the engine, introduction, and in this module now we'll learn what are the components, electronic components it is an electronic engine, electronically controlled engine. So we'll be using uh, what is called electronic components. All right.
Are for the educational purposes, for the benefit of the sea-going marine officers, marine engineers, present and future, also for the technical staff at the ship manager's office ashore. However, you are free to donate voluntarily to the creator of this course and the author without any prejudice. You can donate at paypal.me at or oblique DCE prof. It's up to you. Thank you.
Okay, cylinder control unit. One CCU for each unit. No redundancy. There's only one for each cylinder. If CCU fails, does this question come to your mind? If the CCU fails, yes, we will see what happens when the CCU fails of the particular unit. So CCU, of course, control fuel injection. How the fuel injection is controlled? Through the FIVA valve. What is the FIVA valve? FI is fuel injection and VA is ball actuation. In earlier designs, there were two separate valves that were used. LFI for controlling the fuel injection, electronic fuel injection, and ALVA for controlling the exhaust valve operation, electronic valve actuation. Two separate controls were used for fuel injection and exhaust valve actuation. So electronic fuel injection, LFI, electronic valve actuation, ALVA. Later on, a combined valve was designed, which was called FIVA. LFI, FI taken, ALVA, a VA taken. So it became FIVA valve. FIVA is fuel injection valve actuation. So fuel, same valve, when injecting fuel, is acting as a proportional valve. Because the amount of fuel has to be varied. How quickly fuel has to be released. With what intensity fuel pressure has to rise. Multiple injection is also possible. One injection and the injection stop for limit small time and then again injection to control the NOx emission. So that for that reason it has to be proportional valve. So fuel injection is a proportional valve. And VA, valve actuation, is of course direction valve is on off. Exhaust valve need to be open. That's all. You do not, there is no way, neither is a requirement that you open the exhaust valve partly or 1/3 or two-third, isn't it? There's no requirement. So VA is directional valve and fuel injection is proportional valve. Is that clear? Fuel injection, proportional valve. This we have discussed. Okay. Starting air valve. On off valve. This is also need to be on off because pilot air need to be admitted to the required uh, starting air valve or not required. Earlier, the pilot air was admitted as per the distributor. Nowadays, there is no distributor. So, pilot air need to be admitted to the required starting air valve of the required cylinder as per the algorithm, as per the ACU. Because the tacho system will provide the information. Starting sequence is exactly same as conventional engine. Same firing order, same everything. However, there is no distributor. On-off valve is a solenoid valve. So, this solenoid valve will get an analog signal. So the pilot air will enter into the required starting air valve of the cylinder. And when the pilot air enter into the cylinder, starting air valve, main air is always available. Starting air valve open, main air enter into the cylinder. Cylinder will turn, engine will turn. So pilot, which admits pilot air to the respective unit, starting air valve, which is in starting position, as per the telegraph command, ahead or stern. All right, this is straightforward, correct? Do you have any questions so far? Okay, I have a few questions for you. Hmm? If you do not have any question, so why there is only one CCU for each unit, and why not two, as in the case of ECU and EICU? Because redundancy for CCU is with multiplicity. It is not expected naturally that all of or more than one CCU will fail simultaneously. It is not expected. Therefore, redundancy is not required for using two CCU for each unit. Now tell me what happens when CCU fails? Hmm? Naturally, fuel injection will stop, exhaust valve operation will stop, cylinder lubrication will stop, unit is practically cut off. Engine can run at low speed because other units are firing. With one unit cut off, it's kind of that one unit is cut off on the engine. With one unit cut off, till that time CCU fault is rectified. So engine can still running. So there is no death and life and death situation. All right. Of course, starting air valve will not work. But when the engine is running, you do not need starting air valve. Correct. However, since the engine is running and piston is moving, it cannot be allowed to run without cylinder lubrication. That is important. All right. Once CCU has failed, that means the particular unit, let us say number 3 unit, has stopped injecting fuel. But its cylinder lubrication has also stopped. But the piston is moving as the engine is running. So what do? Can we run the engine without cylinder oil going to the unit for the liner? No, we cannot. So immediately, if the CCU has failed on the particular unit, we cannot wait. We had to supply. We had to two things we can do. You first thing you try to revive the CCU by putting power source A and B off and put on. Sometime the CCU will become will get revived because if the system it is because it is software operating in the MPC. Like any system, the software can be hung up. So that is one way. If not, then you have, if still CCU remains failed, then you have to replace it. But before that, we had to supply cylinder oil to the affected unit. That is important. So how do we supply cylinder oil to the unit if CCU has failed for the unit? We'll find the answer. It is very important that cylinder oil is supplied to the unit as long as piston is running in the liner. All right. There's the emergency cable. I can tell you right this much right now. Later, how exactly that emergency cable is used, which will make sure that the lubrication is taking place even though unit is not firing and exhaust valve is not operating or closed. Okay. But remember that cylinder oil has to be supplied to the unit. Any another question arises? Can you replace the CCU when the engine is running? Yes, indeed. In this case, once you have supplied the cylinder lubrication to the affected unit, you can remove this CCU and put another one. All right. And when it will start work functioning, it will start injecting. And that time, the lubrication which you was carrying out using emergency method, remove that and unit will start working normally. Okay. But I will explain it once again in later module. Okay. ACU, auxiliary control unit. Auxiliary control unit. So ACU control the pressure of the hydraulic power supply system. Okay. They also control the start and stop the electrical starter pump using the pressure set point given by the ECU as a reference. Engine operated hydraulic pumps are also controlled by their respective ACU. So there are, of course, engine driven pumps and electrically driven pump. Naturally, when engine is stopped, you need to have a electrically driven pump, isn't it? Electric motor. Hmm. So All right, correct. So now, when the engine starts and picks up RPM, electric driven pump must stop. So there is a pressure set point where the electric driven pump will stop, and pressure will be now managed by the ACU as directed and built up by the hydraulic pump attached to the engine. Furthermore, the start and stop of the hydraulic blowers are also controlled according to the ACU, and of course, as per the scan air pressure. When during maneuvering, scan pressure drops to certain value, normally 0.25, auxiliary blowers will start. When the pressure built up, depending on the engine, 0.5, 0.6, 0.7, whatever the set point, auxiliary blower will stop. Auxiliary blower can be started manually also and stopped also. Remember that. The control of auxiliary equipment or the engine is normally divided among the ACUs. They are depending on 1, 2, 3 ACUs in the engine, depending on the size of the engine. In the event of failure of one ACU, there is sufficient redundancy to permit the continuous operation of the engine. What will happen if, let's say, there are 3 ACU? One ACU is failed. So naturally, the pumps which are controlled by the ACU and the auxiliary blower will not get any signal, will not be controlled by that. So we'll see how it affects our system. All right. So we'll see later. Control of hydraulic power supply. Hydraulic pumps are variable delivery axial piston pumps. Variable delivery axial piston pump. That means the delivery quantity of the few hydraulic oil they deliver can be varied from 0 to whatever is their maximum limit. Depending on the size of the engine, there are 2 motor driven pump or 3 engine driven pump. All right. At engine standstill, motor driven pump shall run, of course, and maintain a hydraulic pressure of 250 to 300 bars. When engine starts, an engine driven pump develop pressure, motor driven pump shall be stopped by the respective ACU. Engine driven hydraulic pump. So ACU control engine driven hydraulic pump, electric motor driven starter pump, and swash plate control. What is swash plate? What is swash plate? Remember that. Ask me. All right, because I right now because there we are discussing. I'll discuss this hydraulic power supply in detail in later module. But remember that control of auxiliary blowers in auto mode. All auxiliary blowers will be started sequentially at the prepare start. When MOP, you put auto mode, and you start, you got what is called prepare start, sequence start of auxiliary blower will take place. Auxiliary blower start stop input is from ECU. As in the conventional engine, auxiliary blowers are controlled by the scan air pressure, stopping at 0.7 or 0.7 or 5, whatever, and start at 0.25 or 0.3 kg per centimeter square. If during maneuvering, engine stops for more than 15 minutes, auxiliary blowers will stop. At engine start command, blowers will start sequentially. Until the time blowers have started, engine will not start. Isn't it? So some ship pilots and master a bridge people have complained. So certain ship they have increased this timing of the engine and the blowers to 30 minutes. So you see on your ship, this timing can be adjusted. In manual board, of course, they are controlled by the operator. You can start and stop the blowers.